Hello everyone, and welcome back to Feed My Sheep, Earthquake Reports and More. I'm Terry Rempel, and it's the 20th of December, and we've had a large earthquake in California, and this is significant. There's some damage involved, and there's some greater implications with this earthquake than many realize. Before we get into this, all of our programs are dedicated to our Heavenly Father service, and we'll begin with a prayer. Thank you, Heavenly Father, that you keep this program for all of us, for your children to watch, and all who are drawn here to see this information. Jesus, we thank you for shepherding us to good information. I was up at 3 o'clock this morning when this earthquake, just after this earthquake came in, and on the data, and that's thanks to your providence. And we thank you, Holy Spirit, for giving us the greater understanding that we need of world events and how they tie into prophecies, as well as we approach great tribulation in end times. And we thank you for all of these understandings. In Jesus' name, amen. And so, the earthquake here, let's have a look at it. And this is a relatively recent shot. We've had over 70 following earthquakes, and you'll notice, okay, the main earthquake is right here, and the centering of earthquakes is spread, is not just focused here. It gets offshore, and it has mainly an east-west trend, okay, and it's got some width, but it's mainly trending east-west. We got one lone one down south. Got one here right on this is the Mendocino Ridge, and this is important because this is the Gorda Escarpment in this area. So this is actually the Gorda Escarpment's down here, but this relates to the continental edge of the continental plate where it intersects with the Pacific plate. And why are the main trending faults are northwest to southeast, so this direction. These earthquakes are trending east-west, quite perpendicular. They're actually they're trending west southwest to east northeast. So that angle is opposite to this angle, right? So where do these faults come from? These faults come off of the Mendocino Ridge. So the main trending faults, as this breaks in underneath, this fault is going to extend, the Mendocino is going to extend well underneath as part of the subduction zone. And right over to, it intersects with, I believe, Mount Lassen in the direction, if we continue the direction across. So this fault is a major impact underneath the continent where it's being subducted. Okay, and these are following the faults, the trend of these faults from the Mendocino. You would get fracturing in this direction rather than the main continental fractures going in this direction. So with this clustering of faults, or clustering of earthquakes, it's telling us what faults are being followed. That's a big deal. Why is it a big deal? Here we're looking a little closer. We can see there's a bit of a cluster. There's the main earthquake here. Now, the agencies call this a 6.4 based on damage assessments, and there's a lot of damage being shown on YouTube videos. There's power outages. Apparently, there's some cracked roadways. This is looking more like a 6.8 and maybe even a 7. The duration isn't terribly long, but you don't need to have long duration to have a higher magnitude earthquake. The severity, the speed of the movement, and the amount of vertical displacement involved with the movement makes a big difference. So how large the waves are in a vertical manner. So if we have a subduction event, which actually occurred here, if we can show evidence that this was subduction, then as the continental plate shifts over top of the Pacific plate that is being subducted, shoved down underneath it, then you're going to get lots of rise and fall because those are not smooth surfaces that are riding over top of each other. So let's move along and see what's going on. So I was up, like I say, at wee hours of the morning. I was certainly up at 3 o'clock assessing this earthquake. And so it's 1.5 to 2 miles offshore, about 8.5 miles southwest of Ferndale. And there was about 20 smaller earthquakes that followed it, and the largest of these was a 4.6. Now there's been over 70 secondary earthquakes, and we just had a 4.3 registered as part of this extension of earthquakes, secondary earthquakes. And rather than just aftershocks located right in the area of the earthquake, we're having an extension of the earthquake event into a swarm that is spreading out. And this swarm, when we go back and look here, we look at the size of this swarm, and I'm missing one that's down at the bottom here, but we're looking at about 40 miles on land and about 30 miles offshore. That's 70, 80 miles east to west. And then we're a good 20 miles north to south in this band. You can look at this as a band of earthquakes from here to here. And so that's a massive big area. That's unusual for an earthquake to have that spread, and that tells us that different things are going on than just a normal surface fault earthquake event. So the first earlier earthquakes, the early 20 that were reported as aftershocks, were in the mainly in the 2.9 to 3.5 range, and the magnitudes have only dropped a little. And in fact, we just had a larger one at 4.3. So they're maintaining decent size in the felt range. And there's, like I say, reports of damage and to homes and roadways, and images on YouTube of that. So the big question is, what kind of an earthquake did we just have? And so we looked at the Gorda Escarpment, the Mendocino Ridge, and we get a geologic story from this. We've got movement out on the edge of the continental plate, where it intersects the Pacific plate. There's earthquakes there going north-south that we pointed to, and that indicates movement in this area. Let's get to the other picture, better image. So this is the edge of the plate here, and that's where the earthquakes are in this area. This is the Mendocino Ridge coming across here, Gorda Escarpment down here. So movement between the Pacific plate and the North American continental plate. That's about 15 miles or so, where there's showing 4 earthquakes, and there's probably more. They don't report all of the offshore ones quite as well. So the trend of these earthquakes tell us we're having a shift of faults that mainly trend east to west, and it's only in the Pacific plate that you're going to get those faults that fracture off of the Mendocino Ridge, impacting the continent, are going to maintain a degree of the same trend as the Mendocino Ridge. So they're going to be mainly east-west. And so that's why we're seeing the earthquakes trend east-west. It's following the fractures of the Pacific plate that are in the Pacific plate. And it's causing earthquakes, of course, in the surface, because when it moves underneath, it's going to move between the Pacific plate and the continental plate as well. So you're getting a lot more up and down with these earthquakes than you would otherwise. This has all the evidence, because of the great spread of clustering earthquakes, that this is a subduction event, and that's a very unusual thing, to have a subduction earthquake as part of this in Northern California, in this area. Most of the earthquakes are associated with surface faults, not movement between the Pacific plate and the continental plate. So it's movement of the deep Mendocino fault and related splay faults under the continental plate that would create this pattern, but there must also be movement between the continental plate and the Pacific plate for this to occur. So based on the size of the initial earthquake and the pattern and the location of the secondary events, we have just had a subduction event earthquake. And that's a big deal. Now, we have to keep in mind that subduction zones produce the largest earthquakes in the world, excepting things like asteroid impacts and pole shifts and brown dwarf plate shift events. There are some other things that are quite rare that can be larger, but for straight up earthquakes due to tectonics, subduction ones are the biggest ones. And major subduction earthquakes can hit magnitude 10 plus, but the agencies don't want you to worry, so they say 9.5 is about the maximum. And we've shown evidence of downgrading earthquakes, and even very, very large ones. The one in Japan, Fukushima, that was much, much larger than what they reported. So this was a large and damaging earthquake in the 6.8 range, maybe hit 7. I don't think it hit 7, though. But consider what a 7 is. It's 150 times smaller than magnitude 9.5. 150 times smaller. So when you consider that there's damage with a 6.8 to the degree that we're having now, can you imagine how much damage there would be with a 100 times larger? More than 100 times larger. Now, what are the primary concerns related to this earthquake and swarm? The first one is volcanic, and the rates of reactivation of dormant volcanoes vary greatly. Based on studied uplift and tree kill evidence, the Cascades reactivation process of all the volcanoes, volcanic fields along the west coast of North America has been ongoing for over 20 years. It was more sporadic and it's become more widespread. There has been solid seismic evidence of reactivation, which indicates nearer surface activity since the summer of 2018. And we've been pretty steadily presenting that evidence. It used to be through another program that I was on, but on this program for the last couple of years. Movement of the continent that feeds subduction-built volcanoes. So what happens is the continent of North America, proven by GPS stations that are set, and it's called the process of geodesy, but they put GPS monitors on continents, and they know that all of continents, not just North America, they're all moving into the Pacific. The Pacific Ocean is actually getting smaller while the Atlantic gets larger. And that's why we keep having backfill volcanic infill of the mid-Atlantic ridge. So as that spreading occurs, remember, something liquid cannot push a solid. So all it's doing is backfilling along the mid-Atlantic ridge. It's not pushing apart. You can't push solid with liquid, even semi-liquid. So that backfilling ridge is further evidence, and so are the magnetic stripes. When the pole shift occurs, it locks in the direction of the pole when the magma freezes. And so when you get magnetic pole changes, it's recorded in the magma, and they can see the magnetic stripes all across the whole ocean floor of the Atlantic. So this process, at one time the Atlantic Ocean used to be a ditch, and it just kept spreading. So that's the process, and that's why the Pacific is getting smaller. The continents are all moving into the Pacific, the main continents. So this is, rather than the Pacific plate moving underneath the continent, as is generally explained, it's actually the continent that is moving over top of the Pacific plate, and it's forcing the Pacific plate down and underneath, and it melts when it gets down deep enough. Part of it melts, and that's what feeds the Cascade Range volcanoes. And that's why it's important to recognize that the Cascades volcanoes have actually been reactivating by proven studies through USGS of uplift around Sisters, infill of Long Valley Caldera, and also studies done around Mount Shasta. There's proof of reactivation going back over 20 years. But then we get back into old imagery that we're able to access through Google and tree kill, because the carbon dioxide that comes out of magma, and magma is high in carbon dioxide. One volcanic eruption produces, one good size volcanic eruption produces more carbon dioxide than all of mankind has in the history of mankind being on the earth. So do termites, for that matter. But regardless, the amount of carbon that is produced by magma causes tree kill, because it comes up through the cracks. Tree roots need oxygen for the tree to live, and the carbon dioxide comes up through the cracks. It displaces the oxygen and it kills the trees. So it's not heat that's necessarily doing this, but the majority is done by carbon dioxide as magma rises through pressure, rises through cracks in the ground, and also the cracks, faults, and the CO2 rises through the cracks. It kills the trees. Okay, so we've got tree kill evidence going back a long ways. And we've presented that as well. So this is not a new thing. So reactivation of the Cascades has been ongoing for over 20 years. And reactivation of volcanoes, dormant volcanoes, can be faster or slower. There's no set speed for it. So what are we looking for? With volcanic, we're looking for precursor signs coming from the Cascades Range volcanoes. Now, we know from Mount Lassen there was about 150 steam blasts in the something like 9 months before Mount Lassen erupted back in, I think it was 1913, 1911, 1913, somewhere in there. And so Mount Lassen produces a lot of steam historically, which gives a very good indication, warning signs of an eruption. So that's what you look for with Mount Lassen. And Mount Shasta is probably not too much different. Now, before a volcano erupts, you typically get clusters of earthquakes, and these are the early warning signs. Now, we've been having occasional earthquakes and the odd cluster, but it actually goes from clusters to swarms. Swarms of earthquakes at volcanoes are a second step up from having clusters. We haven't gone past having occasional clusters at this point, so we're still pretty early in. So if we start seeing more clusters closer together, and then swarming, then we can be concerned about eruptions. And the next thing we look for, the next stage warning sign, is that we have larger earthquakes. So we start getting into the 4s and the 4.5s, the earthquakes at the same volcano having a couple of these in a week. And that's a moderate to near threat warning level for a volcano erupting. So there's lots of things to look at for warning signs from these volcanoes. The Cascades have certainly all reactivated, but that doesn't mean they're about to erupt. We're going to look for more warning signs from the volcanoes before that becomes an issue. Now, the second concern we have is that there's going to be pressure transfer. When they've released pressure, the continent has released pressure of subduction along this area. And we can see it happening. That's why the earthquakes are there. They're releasing pressure. What does that mean? Well, for about 5 years, I've been pointing at the reactivating Cascades volcanoes as being caused by the process of the continent moving over top of the Pacific plate in a process called continental creep. And it's been a little bit in the north, a little bit in the middle, a little bit in the south. And it's been just quiet little moves that have started the process of subduction that is feeding these volcanoes, and that's why they're reactivating. They're being fed new material underneath. And that's why we're getting uplift fracturing at all of these volcanoes that I've been showing. Infill signals and uplift fracturing, flank fracturing, steam releases, and hotspots. We've shown all of this. And so this pressure is building, and the subduction fills the volcanoes, but it's the only thing that's holding back the Great Cascadia, and this is the big issue, is when is this overdue? I mean, by average, the Great Cascadia earthquake is overdue, and that's expected to be, by the experts, about a 9. I think it's going to be actually closer to a 10, but regardless, it doesn't matter. It's going to be a massive earthquake. And the only thing that restrains the Cascadia is friction. So when pressure overcomes friction, then the Cascadia is released. So that's what we're concerned about. And is this earthquake a precursor sign? And I believe it is. When you've had reactivation of volcanoes going on, what it's doing is it's causing more and more melting in the contact zone between the Pacific plate and the continental plates. And that every time you melt off more, you reduce friction more. And so we've been showing evidence of magma channel activity as well as part of this. And certainly there's increased magma activity, reduced friction developing through the Cascade Range. And so that contact zone is having less and less friction. And now we're seeing a result of that in that we've seen this what they call a 6.4, more likely a 6.8 being released. That's caused the damage on the inland of the Mendocino Ridge. And with the size and with the cluster, we can recognize this as being a subduction event. And so with that size, we also see it as a precursor to more subduction events that are precursors to the Cascadia. Now, back when the Cascadia last went with a massive earthquake back in 1700, there was a precursor earthquake 1 month before the New Madrid fault had a big shake, only reported by priests that were in the area, so the evidence is pretty thin. When you're going back over 300 years, that's just going to be the case. There's not very many people that are going to be reporting it. But that was the evidence back then. So it's not well known, but there are precursors to the Cascadia, and I see this earthquake being a subduction event and it being a precursor to the Cascadia. So you're going to get, when you release pressure in one area, it puts pressure to the north and to the south. And what we've shown is that the south end of the continent of North America moves a little faster than the north end. There's a bit of a swing involved. And this is shown by the flow out around the Caribbean islands. So you can actually see a flow in the plates as the rock deforms and creates a flow and volcanics associated with it. So that means when we get earthquakes in the south, there's going to be even more stress placed further south. We've seen some large activity in Mexico. Now we've seen some activity, larger activity in the Mendocino Ridge area inland. And what's in between? Well, the big fault areas, there's a big fault series that goes in through San Francisco, right, goes east-west underneath the bridge, and right in through San Fran, through the bay there. And that goes quite a ways inland. We've been able to link earthquakes following that fault system that's not well reported on, not well established. And then we have magma channels that have been active in LA. Both LA and San Fran are areas at higher risk than other areas as far as I'm concerned. We don't know what the near-term outcome is. There's a greater risk, technically, statistically, there's a greater risk of another earthquake when you've had a large earthquake. So one large earthquake can relate to a second large earthquake. Statistically, that's valid. But we can't predict that that's in fact what's going to happen. But we do know that by plate tectonics, North America moves faster at the south end. So when we've had one near the south end, California south, mid-south on the continent, that puts more stress on the central and southern California. So that stress transfer is part of the issue now. And we may not see an outcome of that for 6 months. Stress transfer doesn't happen quickly because we're dealing with 70 miles thick of rock. So it doesn't necessarily transfer the stress. It can transfer it quickly, but it doesn't necessarily do that. And only rarely does it do it very quickly. So it's likely months down the road that we're looking at higher risk level events for San Francisco and LA from this. So that's about and now when is the Great Cascadia going to happen? I think rather than looking 50 or 25 years out, because this beast of an earthquake is well overdue already. Now we're seeing a precursor event, and we're looking now at maybe 3 to 5 years out. And I'm not saying I know, but I'm saying rather we are seeing larger signs, and this points to sooner rather than later. As to the date, only God has that understanding. I certainly don't. I expect there will be other warning events before the Great Cascadia earthquake, and I think they'll be up in the 7.5 to 8.5 range, that large, and still not be the big event. I expect all of North America to move in this next Cascadia event based on reactivation of volcanoes in BC, in Alaska, in southeast Alaska, and in Mexico. It's the whole thing is reactivating, and it's subduction that feeds all of these volcanoes, and because they're all reactivating, then some process of subduction is occurring on a small scale. And that means all of North America is already somewhat on the move on a slow basis, intermittently in different places as the stress is released and transferred. So we've been seeing this building for over 20 years, this process building for over 20 years, and we're getting closer to the event. So that's the context. Now, here's how the earthquakes look on seismographs. You might as well have a look at those. And this is how it looked in Mayfield, Idaho. Okay, so we're a good distance away in Mayfield, southern Idaho. We're close to the Snake River there, I believe. So a good-sized earthquake, good propagation from Manton and west, and that's west of Mount Lassen. That's not a great image. Doesn't blow up well, but you can see the spread of secondary earthquakes in here down at the bottom. And looking from the south flank of Mount Shasta, you can see the earthquake is much the same duration across here. We're looking at a good 5 minutes of a large wave signal. And that gets us up in the area of a 6.8 to 7 quite easily. And this is a very near seismogram, and all the near seismograms are underreporting the size of this earthquake. You can see that this earthquake here at Mount Shasta and this one here, this one I've taken this one a little later in the day, but it's the same earthquake. And it's so much smaller, and man, this seismogram is so much closer. So all of the seismograms in the area of the earthquake are underreporting size, but it doesn't mean it was smaller. And we can prove this also looking from using the USGS and looking at their reporting. Now this is Mount Lassen, and this is just on the west side, at about the base of Mount Lassen on the west side. And so here's the duration of the earthquake, and that's pretty significant that it shows this large. That was a big earthquake. There's some of the larger aftershocks. There's this last one is about a 4 point. They called it a 4.3. This one's actually about a 4.7. So they're underreporting this one because the 4.6 they're reporting would be this one here, and this one's larger. Now I talked about the volcanic impact of this earthquake. And what do we see here? Now, this is all magma infill at Lassen, showing from the west side of Lassen at the base, before the earthquake, and somewhat after. And what do we see now? We see steam. These are all spikes of steam, and these are big steam releases from the west side of Mount Lassen. These are big. So we're seeing a bunch of steam already being produced by Mount Lassen. I'm not saying we're up in the steam blast category like they were back in 1911. I think it was 1911, 1912. They had the steam blasts that they were reporting in the papers then. But some of these may be audible if you're close, but I don't think they're being blasted over miles where you can hear them miles away. But that's still, on seismographs, we're seeing a lot of steam release activity. Each one of these is a burst of underground steam flashing from water under pressure in magma to steam, and that causes a big spike explosion of steam. It's an inner volcano steam explosion, and that's what causes these spikes. And what do we see right after this earthquake is a whole bunch of spikes of steam. So exactly the process that I'm talking about is what is occurring. Okay, it's shown on the seismograms. So there we have it. I hope you've enjoyed this program. There's no cause for great alarm. There's a lot of things to watch for. So this is a time to be vigilant for the earthquake activity from the volcanoes, the amount of steam that's being released, showing on seismograms. Some of this is technical stuff, but that's what we need to watch. We need to look for clusters of earthquakes and swarms of earthquakes at the volcanoes. We also have to pay attention to the risk, and God gives his warnings of what's upcoming, and we are very fortunate. Nobody really understood that there were precursor signs to the massive Cascadia event, but the precursor signs that we've seen already are infilling at all the Cascades volcanoes all up and down the west side of North America. And that proves that subduction creep process has been underway, because that's the only way for all of them to be reactivated. Secondarily, we're getting other large events like this subduction event, small in terms of subduction events, but still a damaging earthquake, a significant size. But it's a warning sign. We've got more to come. We have an overdue, as compared to the average, the Cascadia is overdue. And when it occurs, it's going to have some major effect, because the pressure buildup is very significant. When it releases, the scientists expect that the hump in the continent that goes inland about 70 miles, that's going to flatten out, and it'll extend the continent about 20, maybe 25 feet out to the west. And that's going to create major changes in land heights and a lot of destruction. And there's going to be some tsunami activity as well, because there's some offshore faults that are going to shift in this event from all the indications that we see. So big deal. This is a big deal. Not the downstream warning that we get from this quake is what the big deal is. And I'm very sorry for those that have damages and have issues of damage from this earthquake, and I hope that there was nobody hurt or killed. There's no reports of that so far, but certainly this is not an easy time to deal with damage just before Christmas as well. But we have to keep our eyes on the future and what this portends and how this fits with end times as well, because large earthquakes, there's 4 of them that are listed in the Bible as large earthquake events that are part of end times. All right, so I hope you've enjoyed this program. Give us a thumbs up, subscribe, share us with your friends, and we'll see you next time on Feed My Sheep, Earthquake Reports, and more. Bye for now.